slide, please. I don't know who's controlling it, but...
Kirti, could you please change the slide? Yeah.
Thank you. You already mentioned the Open Smart Grid Protocol Alliance. Oh, that's too fast. One back, please. The Open Smart Grid Protocol is a non-profit organization dedicated to promoting the adoption of the Open Smart Grid Protocol. Can I have one slide back? The members are utilities and the stakeholders. No, the other way around. This is forward. Yeah, this is it. We're getting it right. So members are stakeholders in the utility industry, DSOs mainly, but also suppliers to DSOs. They all share a common goal, and that is promoting the standard for the energy transition, taking into account the changes in demand side management, grid management, and the need for smart meter systems as a basic requirement. Truly open standard published by ETSI and Senelec and EIC. So, yeah, next slide, energy transition will happen also in Africa. So while I've done in the past 20 years most of the smart grid projects across Europe, a bit of Middle East, but also in Africa, specifically South Africa, but quite some other countries are and have taken off as well. Now, you might have a slight delay versus, for instance, Western Europe, but take advantage of that by learning from what was done in Europe and who got it wrong. Because the electrification in Africa, of course, will happen as we speak, but at the same time that goes along with decentralization of generation. More and moreover, decentralized generation and storage go hand in hand. The price curves are changing, so it's more in reach of small villages, communities to generate their own energy. Electrical vehicles will take off, and of course in Europe there are quite some countries where it has taken off big time. To mention, for instance, Norway, but even in the Netherlands and my own country, it's taking a significant growth. In fact, more electrical vehicles are being sold than traditional petrol cars. Solar panels and rooftops, on rooftops from private persons, but also in shopping malls, factories, are taking an enormous growth. In many cases subsidized, like wind farms. But that basically causes trouble as well for many of the grids, because the grids, as most of you know as professionals, was not built for that feed-in, the bidirectional flow of energy. Now, that significant demand increase, have in mind not only the electrical cars, but computer centers, data centers as well. The demand is increasing significantly, despite the fact that many of the devices today are much more energy efficient. The load curves, which were used in the past, are history. You can't use them anymore. You need to have real information, data on what kind of energy is requested where. Communities are joining forces. They basically sit together, and that's what we see starting to happen in Europe as well as in Africa. Communities now can jointly pay and basically own generation as well as distribution network locally. But then the big question is, who controls the system? Because normally those systems, decentralized systems, are not disconnected. They are connected for a good reason, that once in a while they need to take energy or feedback energy into the other decentralized grid, microgrid, or to the main grid. But then somebody needs to control the energy flows, the voltages, the frequencies, and so on. Now, Africa has some unique attributes, and that is, I want to mention dual sourcing, where people are nowadays used to basically, when they're cut off from the main power supply, to have the diesel engines running. That is a sort of unique situation, which you don't have like that in Europe. But you also see that commercial property owners, landlords, are selling energy to the shops, the residents as well, which is sort of different as well. But this basically creates as well the opportunity for those parties to start being engaged as a distribution company as well, and of course generating and selling. Next slide. Now, if you look at the network, for, I would say, 100 years, it was pretty simple. The upper part of the slide, generation, transmission. No, one back. Generation, transmission. But if you look now on the bottom side, you see the current world with decentralized generation, with solar panels, with wind farms, and so on and so on. And on this chart, it looks like, well, pretty clean, well organized. But if I can have the next slide, the reality is quite different. The reality is that it's a mess. Energy flows from anywhere to everywhere. You see it quite nice reflected on this slide, one too fast on this slide. And this causes a problem. As said, in most DSOs, there is no measurement, there is no insight on the low voltage grid on the energy flows. In fact, even the topology is not quite known. Which homes are connected to which feeder, on which phase. In some cases, it's not even known which transformer. And of course, if you want to control the energy flows, if you want to really optimize the energy flows, ensure that you can store or manage loads, manage demands, you need to have proper insight. And that, of course, is today not the reality. This picture, which you now see, is reality in quite some countries, and it does cause trouble where the utilities, the DSOs, say, stop, I cannot provide you energy, stop, you cannot feed in energy, my network is not capable of transporting the amount of energy, either way. So, next slide, please. The old view and the new view of smart metering, and in fact the DSO, is that where in the old world the consumer thought, well, if I get a smart meter, I don't need to basically send the data and then nobody will come to read the meter. And the DSO thought, well, it's convenient to have the data for billing. It now basically becomes a very different game. And the new view, the smart meters are essential for the consumers as well as the DSOs to give insight in what they generate, what they feed in, what they use, how they can take advantage of very different tariff structures and so on. And the DSOs, they need those smart meters as sensors in the grid to know what's going on. So the integrated, digitized network will be a reality with a significant focus on the low voltage grid. There is the need for increased information about the demand and how you can handle the demand by different tariffs, by smart equipment. These days, there are washing machines, as an example, sold, which have an ability, and they're Wi-Fi connected through the internet, and they have the ability to be controlled by the DSO regarding when they're switching on and when they should be ready. And the consumer can set, okay, you can switch it on whenever it suits you, so that not all washing machines start at 7 or 8 in the morning, but throughout the day, as long as it's ready at a given set time. That is the new world, but of course, that means everything is connected and digitized. Next slide. So, in a bigger perspective of a smart village, a smart city, you see the different elements which play a role in that multi-dimensional world. And grids are talking to buildings because changing set points for half an hour so that the air conditioners in a building, in a shopping mall, is changing for 20 minutes, half an hour, might help overcome a peak demand. Lighting, transportation, the decentralized storage in case there is an overload of energy generated, everything now hangs together. And what that means is basically the requirements on the left-hand side. There is a lot of information flowing between all the parties. So protection of information as well as the service and the SLAs are essential. The energy efficiency, really manage the grid to optimize the energy flows, optimize the storage. Don't let energy which could be generated stop generating because you cannot handle it. The decentralized consumption, storage and generation becomes way of life. And asset management is essential in the business case. Asset management in most cases will pay back for the whole new infrastructure. But it comes along with some key requirements, key features you need as well. That is security. With so many endpoints, not tens or hundreds, but 10,000s or more. Endpoints which basically are an access point for a hacker. And I'm not talking about a hobby hacker, but professional organizations, criminal organizations, or countries trying to derail the system. It all hangs together, so communication, a significant amount of communication. The amount of data is immense, so you need analytics to highlight where you really need to dig in. And that is a constant changing world, so the monitoring of the infrastructure will be needed 24 hours a day. Every minute you need to see what's going on because the dynamics are as such that it's changing every minute. Next slide. So this new world means requirements for new low voltage grid inside applications. One back. There is the need for applications which you don't have today. The other way around is back. Yeah, you get it. One more. Okay, so energy and theft monitoring. Of course, Africa, typical issue over there, but not only there. Identify losses, be able to exactly identify where losses occur, where somebody is basically playing around with the cables, with the connections, and basically identify it and take action. Much more information required on power quality, outage detection. Automatically, before people start calling, you should basically get immediately the alarm that there is an outage. Voltage and load heat maps ensure you basically get insight at the transformer level, secondary transformer level, on the feeders by phase. What is the voltage, what is the load, so that you basically can see the trends and act upon it before they basically burn down or switch off. Transformer protection becoming a bigger and bigger issue with the extreme loads, vice versa. Failure prediction, identify again before it happens that a failure might occur. And then Grid Watch, a new type of application we developed with some of the members. Security to the next level. Detect an intrusion, detect if somebody tries to hack the grid before it happens. One slide ahead. Now, the other difficulty one everybody has is what technology to choose. Because technologies, like on your phone, like on your mobile, technologies change as we go. And when you implement the system, more likely the next generation is already available. So what is crucial is that you basically are implementing an architecture which allows you to take advantage of new technology as evolution provides you new technology, which might be faster, cheaper, using less energy, but new technology will come. So, for instance, the OGP protocol is mostly implemented on power line communication, being the most reliable, cheapest for this purpose, but then as well available through wireless technologies alongside. And you can mix and match those. Integration is a key element. If you think of metering, the smart car charging system needs to know how much energy is still available at the transformer level. So you need to have all those subsystems communicating with each other. And SIM, the Common Information Model, is a standard, international standard towards most systems today. Most modern systems are interfacing and as a upper layer language, which allows you to exchange information between the various systems. Accept multiple headends. As technology evolves, every technology has their own, let's say, control application specifically geared towards that type of devices. So you'll end up with multiple headends. But again, it does not matter, because if you have a higher level protocol, then you should be able to have physical layers and logical layers mixing in the IT environment. Data-driven decision-making, it will mean extended IT capabilities required, but of course investments as well. And in the world of today, cloud-based. New financial models, meaning you need to think different with investments. Take smart metering. You can't look at that like in the old way and see the benefit only in, well, I collect the data for billing. No, it basically allows you asset management. It allows you basically to provide the service to the smart car charging systems and so on and so on. So cross-function benefits means different new financial models. And then security is the last, moving to the next level with so many more endpoints, getting more complex, and basically need extended investments as well. Next slide, please. So are grids or DSOs today smart enough for the future? No, by no way. Not in Africa and not even in Europe or wherever. I do believe it needs to be enforced and financed. So it means that responsibility for regulators and governments to allow DSOs to invest in that future, and in fact invest not for what mostly happens today's world, but invest in the future world. Because as we have seen right now, the mistakes made in Europe, investments were done based on yesterday's need, and basically that will not carry forward the DSOs, the utilities, into the future. And they have no insight with their systems. In the low voltage grid dynamics, they have no data or AI applications to handle the data, and so on and so on. So to be ready for the near future, which already has started, financing is an issue. Technology will force you to go there, but it starts with a vision. Starts with a vision, how the world will look a few years from now, 5 years, 10 years. And any decision should basically take that into account and should support that new world. That was my introduction. On the next slide. I don't know if you want to take any questions now, Chairman, or after my confrere presentation.
Yeah, I think the Richard, can question be taken now, or the two presenters should take first?
We'll have Sabine's presentation. So if there are any common questions or they'd like to jointly answer some questions, so we can have their inputs both later.
All right. Okay. All right. So Sabine, I think are you giving a presentation or just some?
Yes. No, there is a presentation. If you maybe can go to my holding slide. Yeah.
Okay, that's fine.
And I will let you know when you go on the slides, because I will shorten it a bit, because otherwise we have too many overlapping activities. But Mark, thanks for the great introduction into my story. So I'm very happy that you see similar trends. But first of all, everybody, welcome. I'm very happy to participate today in the session. And I hope you all who are participating will find some value in what we are exchanging today. But let me, before I show you a slide, just to stimulate as well the discussion around the digital application within the smart grid. If we just have to pause back a little bit, about 3 months ago, COP26 has happened, and the African group of negotiators on climate change went to to Glasgow, and luckily the African continent was put onto the agenda with regards to one of the key enablers to help the globe to reduce the carbon emissions going forward. So two topics actually came out of the summits, and that is, one is climate finance, and Mark spoke to that already, but also the adaptation and the transfer of technologies, but also capacity building on the continent. And these are clearly areas which we need to talk about, and I hope we can go into this later on into the discussion. But the most important part is, as I mentioned, Africa is now firmly on the map for the energy transition, which are going to happen globally. And the continent has joined now the renewable race, and a great urgency has given to basically put investment in place to ensure that investment in and finance in renewable infrastructure is happening while, and we listened to also the session on ESCOM and the maintenance program, while the current infrastructure still has to be kept up, because as you know, we don't have something what we can replace 100% from today until tomorrow. And all countries on the continent are part of this race. There are a few like South Africa, Morocco, potentially as well Egypt, who already have looked at the hydrogen partnerships, particular with Germany for that matter. But there is also consideration to be given for the nature of the African utilities, because one thing we have, many of them are in financial constraints, so they can't just, spend wild on new infrastructure, be it assets to generate electricity, but also the topic of infrastructure in general with regards to substations, smart grid, smart metering, and the likes. So these are obviously a dilemma which we have to solve together. And there are a few ideas also to come up with solutions to it. And one definitely is to help as well, unbundle certain utilities to make it possible to have a clear financial measurement for the investment, for instance, into a transmission or a distribution entity, and maybe also think about to have private companies coming in which are going to help with the investment. And, if you look into South Africa and particular on the renewable RPP program, we do see that it now has, moved forward, and that is definitely a step into the right direction. First of all, to raise the amount of capital you are going to need, but also I see a question on the slides. I'm going to the next slide just now because I'm just talking general, so be patient for a moment. Yeah, but also to help to raise this enormous amount of money from other sources than just from the state. But you see, national grids across the countries on the continent haven't had that attention for investment. And if you think about the discussion about various African moves over the last decades, it was always that Africa needs energy generation capacity, but hardly anybody spoke about the grid and the infrastructure required. And ultimately, these challenges need to be addressed because transmission and distribution, in particular with regards to distribution in the low voltage environment, will become more prevalent going forward. But I also want to pause on one topic before we go into some of the slides with regards to options on technology. One of the aspects we clearly need to consider, and that now goes into the fact of Africa currently is very much still depending on fossil fuels, be it gas, be it diesel, or be it coal for the energy generation. But we also need to know that Africa currently only emits 3% of the total carbon emission globally. And so hence, we also need to be mindful of how fast energy transition can happen and digitalization of the grid can appear within an African context. Technology can be exchanged, and we see that particular on in the developed world where they have massive funding, specifically now after COVID, where they put a lot of money into the energy transition. And I'm talking now about Germany. We have a new legislation or a new government, and they have put a dedicated ministry together for the topic of climate change, where funding is coming forward. In Africa, we don't have that luxury, and we do need to keep in mind when we talk about the grid and what can be the future of the grid, that most probably for an African environment, some of the resources with the fossil nature might linger around a little bit longer than in other countries, because also these resources do generate income for the state and come back to the entities. Most of the power generating units or transmission and distribution units on the African continent are owned by the state. And so if there is no tax collection, there will be no investment into any infrastructure. Yeah? So these things we do need to keep in mind. And I think it's important to be patient as well with the possibilities and the speed we can generate on the African continent. But on one part, which I do believe, and I'm very excited about looking backwards now for the last 2 years of COVID, we have seen that in Africa, definitely digital technologies have leapfrogged incredibly. And if you would have asked me before COVID, would we be able to do it? I would have said, well, maybe somewhere in the future, but not now. But we have seen that specifically when it comes to the digital grid, to smart metering, to meter data management solution, to some of the digital substation technologies which we have implemented with a number of utilities on the continent, we could do that despite that we were all locked off from each other with travel restriction. We used the virtual world to do the testing and the integration together with our partners in the respective countries. And we have seen that the skills and the ability on the continent is already available. And that makes me very proud, because when you look at the slides which I'm currently presenting, you see we did a study on, what will be the future of energy going forward with some of the major energy companies and utilities globally. And 63% of all the people in charge of utilities on the globe, not related to Africa only, believe that there is not enough transformation within the space of the utilities in comparison to other industries. And that is definitely true, because we believed all that electricity is something which comes out of the plug, and we didn't put a lot of thought in, where and how it's managed. But you see here, and it's a bit of what Mark has shown, you see basically the possibilities for smart grid solution really driving the energy intelligence. And it is important, as already alluded by Mark before, it is important to understand what kind of electricity do I have available with forecasting tools, for instance, for the wind technology, for solar, to exactly know how much megawatt are coming into my grid, how at which given point in time of the day. But also you need to know what are my consumers going to do, because if you think about specifically as we are now attracting also onto the continent intelligent industries, like for instance life science industries, and you will know last week during the EU Africa summit, the presidents of Ghana, Rwanda, Senegal and Rwanda and Senegal have had the discussion around having vaccine production on the continent. So if you go into that level of industrialization, we need to have the stable grid. We need to know exactly, when we are able to supply the electricity for the product, because these are highly sensitive technologies which can't be disrupted on a permanent basis. So you see, these areas are clearly moving forward. We also see that we have specifically on the benefits of bus processes, which also reduces costs, because we are now have the possibility since many years. I mean, if you think about when last time we had a massive investment into the grid, it was probably decades ago, yeah, and that is what we're still living on. But now there are a lot of modern technology where you can have digital connections for your substations, for instance, where you don't need wiring and cabling. And obviously, when there is no wire and no cable, it can't be stolen. Yeah, so you have additional benefits from it, and you are able also to detect through the digital application and sensors, as well as controllers, on how to manage a shutdown, but also if there is a trip, nobody has to go out to the substation to start it again. And we can reduce cost, and complexity. And that also helps you later on to keep the system more open, because as Mark already said, technology is evolving, and we as Siemens, we are since many decades in the digital space. If you think about our SCADA system, this is already a leading SCADA system since more than 30 years, where we are the market leader. And you can see that we could adapt our technology with the foresight we have as well going forward in new stages of the development. But I want to pause a little bit on two aspects Mark glanced over at a little bit, and that is cybersecurity and cyber attacks, but also protection of your integrity of the system. Because what we see is that we can have all this technology, but obviously what we don't want to be vulnerable for people which don't have the right intention and want to tamper with the systems through, hacking into your plant or into the operation. So really having solutions and ideally defined clouds, but also having solutions with regards to thresholds and agreements between partners working on the side on how we are going to manage cybersecurity is absolutely vital. But that also goes to who has access control to your system. How do you track and trace changes to the system? These aspects are incredibly important for the future, beside the areas. And if we maybe jump to the next slide, and this would be then also my last slide, beside if you look at new applications coming in, because what we are going to see in the future is as well that you have new technologies coming in, like, for instance, e-mobility, which currently we don't have on the African continent implemented. But I can tell you we did a test case on such a management of e-mobility in this Volkswagen in Rwanda, to also get the understanding on how, a grid can work, what kind of energy for the e-mobilities we can source from a renewable source, because eventually such kind of technology also makes only sense if it's powered by energy which doesn't emit any carbon, because otherwise you can also drive your normal combustion engine car. But it also is important to look at aspects, and for industry and for consumers, particular for listed companies globally, it will be more important also to understand, decarbonization within the utility supply chain. Because remember, many of the companies, specifically in the food and beverage environment, they have made pledges, and I would urge you to go onto a webpage called RE100, where you can see what multinationals have committed with regards to their CO2 emissions and their net zero targets for between 2030 and 2050. And it's important for us, specifically when we talk about the utility space, to consider it, because these companies need to decarbonize their complete value chain. They need to have an auditable trail, what kind of electricity they are going to consume, for instance, to run a plant, to run a mine, or to produce a car, for that matter, if we stay with the e-mobility aspect. And that means we need to be able also to track and trace for the end consumer what kind of electricity he or she or the company has used, because otherwise we might see a de-investment from the African continent if we can't provide this kind of services. But as said, the estimation of what kind of electricity is going to consume, having forecast specifically also on algorithms, on historical data, this is all possible, and that can help you as a utility also to optimize your planning and understanding, what kind of revenue collection you are going to have. And lastly, I would like to turn on one topic which I believe is very important, and that is digital technology with regards to simulations. Because, in the olden days, we would go and install, you would map it out, what kind of electricity structure you are going to have. So what kind of electricity is coming out, what kind of consumer you have, whom you will connect to the grid. But today we can simulate this as a kind of a digital twin. So the digital electricity twin, where you can see what do you really need to do, where you can do without cabling, where you can have digital solutions on the substation and help you really to optimize your asset layout, but also help you to optimize later on your maintenance costs, because you also can use it to train your operators, your service technicians to really understand how things are going to work, so that before they are deployed, they have a good understanding on how to apply the technology. And that obviously, as I mentioned, we have seen that over the last couple of years, particularly during the 2 COVID years, that the African engineers are ready for digital technologies. I have the feeling they're really thirsty for it. And lastly, I want to leave you with one fact before we go into the discussion, is that also 67% of all people which are within the field of the global utilities believe that the future of the electricity infrastructure and the grid is going to be digital, and it will not be possible to achieve the net zero targets globally if we don't use digital technologies. Yeah, I would like to pause here, and I'm happy to take any of your questions. Thank you so much.
Wow. Thank you so much, Sabina. That was quite on point. You and Mark have hit the nail on the head in a couple of points. So we'll go straight to the questions. I'm going to start with Mark. And your presentation really touched on, quite all the areas with respect to smart grid and digitization potential. But I'm going to ask you, with respect to Africa, and with your detailed understanding of Africa's evolvement and evolution with respect to grid technology, what do you think is the main roadblock to implementing smart grid in Africa? What do you think is the main obstacle, to really do it right as Africans?
Well, thank you for the question, Mr. Chairman. Sounds an easy question, but it's complex, because it first of all needs understanding of the problem ahead of us by all parties involved, meaning regulators, Ministry of Energy, as well as the utilities. And in line with one of the questions I saw in the chat, is it an vertically integrated utility? Is it easier? Is the focus on low voltage or medium voltage or transmission? Well, as I said, transmission has been the focus for a long time, but now it's on low voltage. But one of the issues is that people underestimate the impact from the energy transition on the low voltage grid, where they basically are in the blind. They have no information what's going on beyond the secondary transformer. So it's a lack of understanding inside the utilities. There's also a culture gap inside the utilities. Low voltage people and medium voltage people don't talk to each other. Metering departments don't talk to the medium voltage guys, and those were the ones having the expensive equipment. And the low voltage guys, they rolled out some cables. No big deal. However, with the dynamics now changing in the low voltage field, where significant effort needs to be put in place, those departments need to talk together. Because the smart meters, for instance, collect a lot of valuable information to manage the grid. One of the first trends I've seen now addressing this issue is that a metering department, which was reporting to customer service, because in history it was there for billing, metering department is now moving to grid operations department. So for the ones who are responsible for stability of the grid, understanding that those low voltage meters have significant valuable information if you have the right ones. So not let them only use for collecting billing data, but collecting the real voltages, the phase detection, the harmonics distortion, and so on, and have the capabilities, the skills as well to use it. So it's a mix of culture inside utilities. It's a mix of the departments, the systems which needs to be now integrated. And maybe, it starts as well with the financing. The people providing financing need to have that view. There is no option. Sure, there is a business case where you basically have an integrated view of the future utilities. Then there is a solid business case, but also there is no choice. You need to put the money now on the table to prepare for the future. Otherwise, you will gonna see more blackouts, more disturbance in the grid.
Thank you, Mark. That's quite detailed. Sabina, this question goes to you. Similar, but then more directional towards Siemens' understanding of the energy landscape in Africa, knowing that Siemens has a hold of a greater share of coverage in terms of, like in Nigeria presently, we're doing a total transformation, and the government of Nigeria has engaged Siemens on a 3-phase level for a total transformation of the power sector. So, with this background and understanding of Siemens' wide coverage within the energy landscape of Africa, what kind of challenge does Siemens as a technology company face in Africa? What are your findings? What are your own, in specific terms, what are the real challenge, towards this journey or transition to smart grid and digitization?
Well, thank you so much for the question. And you refer to the Presidential Power Initiative, which we are currently executing in Nigeria. And, this is a great example, as I mentioned already before. When people look from outside Africa onto the continent, then they would say, well, there is a power shortage, so we need to have more generation. But if you look particular at the case of Nigeria, well, I mean, you could do with more generation eventually, no doubt. But in the current situation, you are not able to evacuate the current power you generate to the consumer. And this is a problem because it makes any other investment later on not financially viable. So the biggest challenge we see, first of all, is we need to come to an understanding within the utilities on the African continent that we need also to work on the grid and the control of where power losses are going to occur, and potentially also non-technical losses, because if you don't cut this out, you're never able to recoup the investment, be it private or government, on any new generation capacity. So that's one part, the understanding. The second problem, and I think Nigeria, in the case of what we are currently doing, is very unique, but normally what you have is, and this is holding Africa back, is we have utilities which are state-owned, which have to follow public procurement law for many reasons, compliance reasons, financial budgetary reasons. So, but the fact is that the process on, getting a specification out, getting the tender out, having as well specifically in countries which are developing countries, which are getting the money largely from World Bank and other donors, they don't have massive amount of money available to spend in such an integrated solution. And if you look at the presentation we both have given, the thought you have to put forward is to think holistically. You need to think about the whole system. You cannot just think about your substation, your power generation unit, your transmission side, or your metering. And you need to think in a complete dimension, specifically, like if you take city utilities or so, to have a strategy on what they want to do. And then you can see what kind of technology is complementary. What we currently see, and this is one of the big challenges, we have case by case purchasing. And Nigeria, with the Power Initiative, is the first initiative we are doing on the continent, where it's really a holistic approach to understand how to optimize and reduce through the optimization the cost of power. Because eventually, even if you have power, it doesn't have an unlimited price tag. You can't sell it to anybody for $20 cents. Then you don't have customers. You might not do power generation then, So the essence is really to think in a holistic way. And currently we don't see that, because technology needs to, if you specifically think about digital solutions, you need to understand what kind of assets you are going to connect and how you are going to manage it. What will be your protocol to manage it? And really to tap into aspects of power losses, and revenue collection at the end, because also it sounds, an electable aspect, but the reality is that many of the utilities, because the way and how they run the last mile, they're not able to collect the revenue from the customer. And as long as you can't 100% ensure that, you will have a problem with financing any of the investments. Yeah, so there is where we currently see a bit the dilemma now.
Yeah, thank you, Sabina. Your answer raised a lot more questions, and same with Mark. I'm going to ask a question that I also want the two of you to answer, which, as Africa, taking cue from Nigeria, we are trying to move into the future grid, but let's start from where we are. Even where we are, the current technology, most Africans are not efficient in their mode of operation. So, going forward, and technology is not going to wait for anyone. Whether you join the train or not, technology will keep evolving. So, in moving towards the future grid and digitization and the smart grid that we're talking about, how you touch on so many things, just because of time. How do we build capacity the right way? I want you to answer that from Siemens' perspective, and I also want Mark to speak to this. Now, how do we really, and I want you to be blunt as much as possible, how do we really build capacity efficiently, correctly, knowing across the entire value chain, talking about generation, talking about, getting it right with respect to the fuel, like the issue with Nigeria. You have enough capacity, no fuel. So all that, where do you get it wrong? Knowing that you cannot do generation without fuel. Why was that not integrated from the on-go? And a lot of Africans are going to be and companies like Siemens to help them. How do you come up with strategy that is holistic and that ensure that beyond your building the project for them, they can sustain? You have built capacity. The issue of capacity is often left out. And I want you to address, how do we get it right correctly? So, Sabina, please.
Sorry, I had the difficulty. Yeah, look, you're absolutely right. And capacity, one on resources, but also on human capital is absolutely vital. But I must tell you, looking at it from a company's point of view, we did recently a project in Ghana with ECG, and that is a meter data management system. Yeah, and there has a possibility to connect smart meters onto the ECG network and really to manage what kind of electricity they get from the gridco, what kind of and how much electricity are they going to sell to the end users. And actually, when you speak to the end users, the high energy consumers, they're very happy with such a solution, because that gives them transparency, that gives them trust into the utility, because often that is also not necessarily 100% available. And what we have seen is that through the project, through an implementation of digital technologies like a meter data management system, we could also, take with us the utility and help them to get the skills, because unfortunately, because we had planned it differently originally when we took the order, because there was no COVID. But during COVID, we all had to, really, pull up our socks and get more digital savvy. And we see that this is not necessarily a letdown for the continent. But one part is we need to start on a base where we can have a holistic discussion with these utilities to understand what is out in the market, what kind of technology is available. And not always when you meet with a company on the private side, we all want to do business, but I think there's also a possibility, like on platforms like this, to get a principal understanding what kind of technology is there, and maybe have one or two options being presented from different companies, just so that you are familiar on what you can do. And as Mark said, so that the guys which are in the metering department speak to the guys which get the energy supplied from maybe the IPP. On the skills, specifically with regards to human capital, I can tell you, as a German company and through the German government, we have a lot of leverage through agencies available to have skills development initiatives in the country going. But, it is pointless to train somebody if you are not going to implement anything, because by the time you might get it, well, you have lost the skills. So these things have to go concurrent. And as you said, the world is not waiting for Africa. We need to, jump onto the train. But, I'm pretty comfortable to see what's happened over the last 2 years. And yeah, Africa will make it.
Thank you, Sabina. Mark, I want you to speak to the capacity issue across the value chain. And specifically, I've spent 24 years in the power sector, and I've come to see that the capacity building lacking by an operator who climbs the pole is not even as critical as the Minister of Power who signs. When he signs based on a wrong understanding, the effect is more critical than the linesman who does not have enough capacity, or the engineer. So it's across the entire value chain. Different sector, the regulator, the fuel company, the distribution end. How do we get it right, Mark? How do we get it right?
Well, I have a pretty strong view. And first of all, your 24 years of experience, with all respect, is, let's say, I wouldn't say worth nothing, but the future will look very different than the past 24 years regarding capacity, where it's needed, where it's generated. So first of all, you need to be open that the future looks different, future will is different. And in my view, it starts with knowing what's going on in the field. And then I'm talking again, low voltage grid. That's where I would make the first step by implementing through smart metering. Sabina mentioned it as well. Then advanced smart metering, not the cheapest meter, but advanced, giving you the proper information on the energy flows. But as well, it provides you the means on load control, because that's the first step to take after you basically use it for non-technical losses. That's your first payback. But basically start doing peak shaving. Peak shaving is the first essential activity which you need to do. But you need information to know where you have that capability, or where you need, and where you're running out of steam on the transformer, the secondary or the primary. And that applies to the feeders as well. So measuring, using that, have the proper analytic software to inform you. That is the first step to optimize the capacity you've got based on where you know where you've got it. And then, I've seen questions as well on the transmission links and connecting them cross-country, whatever. Sure, that is sort of what is done in the past, but I do believe the balance of power will move towards medium voltage and low voltage. There will be much more communities, cities, independent of transmission grids in the future, think 10, 20 years ahead, than in the past. So, in that new world, and I think Sabina and me, in most of the topics agreeing, start at the end of the grid, at the edge of the grid, knowing what's going on, start to control the peaks there, and then move and build an infrastructure allowing you to have local generation at any level, being a wind farm at medium voltage or at the rooftops on with solar panels, and be able to integrate that and use that energy which is being generated.
All right. Thank you so much. Mark, as we journey towards smart grid, are there standards that we cannot compromise? If there are, what are the standards that, look, this is the minimum that we need to, put in place, as Africans? And in addition, a question from one of the participants, I think you touched on it, was asking, it said, look, do you see more challenge at medium voltage or... So speak to this as I...
So first of all, I see most challenges on low voltage. That's where basically there is a lack of history and nothing was measured and nothing was controlled. And that's where basically by the communities and consumers, it's the first thing which happens. In Europe, by the way, the European Commission, it has become law and that the DSOs need to facilitate different tariffs, need to facilitate end users want to generate or store energy or communities. That's now law. Nobody yet is ready to implement it, but it is law already because the European Commission understood that, you need to appoint to somebody who's going to be responsible. That's a long new business of service providers. But low voltage is key. Technology, as I said, is evolving. I do believe in standards like OGP, public standards, but basically built and geared towards supporting the energy transition, but as well being able to integrate with other technologies and standards as well. Nobody should stick into the standard they knew for the past 20 years and say, I'm going to take that for the next 20 years. No, rest assured that technologies will evolve and new standards will come up. And the biggest challenge is to interface information, to exchange information between different environments. As I mentioned, car charging or storage, with smart metering, knowing the transformer loads and so. So the integration of that, I think, is the key issue, and an evolving standard internationally for that has been some time around is SIM, an extension of the 61850 for substation automation, but now all the other areas are tending towards interfacing to SIM as well as an upper layer. So focus on the architecture, have an upper layer allowing you to exchange information between those fields of automation.
I have just two more questions, and these are from the audience. I'm going to ask you, Mark, which is your last question, before I jump to Sabina. And there are two questions here which look similar. And the question is saying, the creation of a region, it says utilities that suffer from high losses in Africa have not managed to address this challenge. And so do you think the partial funding from developing partners to these utilities can ever be enough or sufficient to address the problem holistically, knowing that they have not learned the culture of addressing even the losses, that existed? And, the second question here was saying, look, the developing partners do not provide an holistic solution that address this area of loss management. And so when you bring in anything on board, it still doesn't solve the problem. So what's your take on that?
Well, let me start. To me, clear. The regulators need to enforce a set of requirements for systems to basically support you into the future of the energy transition. So regulators can set, if supported by the Ministry of Energy, they can set regulation, request functionality to be implemented, which basically doesn't come at lowest cost, but basically is geared towards supporting the future.
All right. Sabina, these two questions, I want you to answer them. That's my last question. First is, how can African utility fast track their pathway from carbon-intensive solution? Why still providing energy? Because we are not going to jump to the future grid overnight. How do we fast track our pathway? And then this is a question from one of the audience. I just want you to take it along. You mentioned that there is cost saving in terms of eliminating wires by using wireless technology in your presentation. Do you see overall cost saving as key driver, or is the smart digital transition an inevitable feature that we need to embrace as the new normal way to invest in the grid today? So, we'll speak to that.
Well, come to the first question you raised. I mean, look, the reality is the most expensive investment is, in general, the investment into generation. And so ideally, you would like to liberalize that kind of generation capacity with private investors. So where you have tough power purchase agreements, where there are also KPIs behind, where there are penalties applied, so that, the state of which is then ultimately responsible for the utilities in Africa doesn't have to bear all the capital investment. Because in some of the countries, I mean, South Africa has a great concept, but in most of the developing countries, they just simply can't raise the loans to invest into new energy capacity. Yeah, and ideally, if you want to transform the energy grid, you also need to talk about then your off-takers. Yeah, who are the off-takers? Is it only the utility? Does have everything has to be just sold to the utility and they sell it on? But maybe if you have IPPs coming in, you have like big industrialized activities, be it in the sugar industry or in other industries, which then buy from that IPP at a defined pricing mechanism. And that also will help to take some of the pressure out. But as Mark said, as we discussed before, the most important thing for these African utilities all over is to make sure that they have decent revenue collection, because the banks, they are pretty black and white. They look at, can you show in your audited financial statements that you get the money? Yes or no? If you can't, then you don't get money. And so putting an effort on collection and revenue collection and making it more difficult for people to steal, for that matter, that needs to be the mission in order to transform it. And I do believe it's possible. But, the thing with power, with the transition is there are also, and you will appreciate that in Nigeria, there are also people in the network which are happy and make money out of it that the system doesn't work. Yeah. And, these ones are not going to the side just because we are all good people and we want to reduce CO2. So the guy who provides diesel to the generators, he will not be happy if you say, well, I'm giving you in future solar power. Yeah. So we need to embed as well. And this is the topic I mentioned on the social dimension. We need to look at, what are the implications for the whole ecosystem? Because if you maybe switch something off too fast, you might create an unintended consequence. So we need to keep that in mind. But it's a complex topic. But I do believe if you start this revenue collection and enforce it, you can then also get a certain discipline into the system. The second question specifically on technology and cabling, but also the most cost-saving aspect is having a digital grid simulation, which also the utility later on keeps as a backup within their system, so that they exactly know what has happened if they are going to replace one thing or another thing. And the digitalization with bringing renewable energy in, which is going to happen because Europe is not going to make the 1.5 degrees, as I said. So the only continent for Europe to do it is in Africa. And so it's a great business opportunity for all of us. But on the other hand, that also means we need to make sure that we apply these digital technologies to satisfy our donors and our business transaction. And therefore, it is inevitable and we need to do it.
Thank you. Thank you, Sabina. Thank you so much, Mark. It was a brilliant time with you.
My pleasure.
Thank you.
Yes. Bye. Bye-bye.
We'll wrap up on these notes. Thank you so much, all participants and attendees, for coming. See you another time. Thank you.
Thank you so much, Sabine and Mark, for a very insightful and a very engaging presentation, highlighting some of the solutions out there for creating smart and digital grids and how these technologies and solutions can add greater reliability, resilience, security to our grid networks. Thank you, Lakin, for a very engaging discussion. Thank you so much all for joining us today. We have actually also received news that Mr. Balsha, CEO of EEP, is unable to join us today for a session due to an emergency. We're hoping he can join us tomorrow for a session, and we will keep you posted on the developments. With that, we will be moving on to our last session for the day, but it is another very interesting session, which is on regional interconnections and power exchange. We are all very well aware that regional power markets can offer extensive benefits to all African countries, and efforts are underway to deepen regional cooperation with the longer-term vision to create a continental energy grid, providing affordable and reliable electricity to all Africans. We have experts from the Southern African Power Pool joining us to share the efforts that are being taken to strengthen the power market in the Southern African region. Today, we are joined by Ms. Jean Madzongwe, a programs manager with the SAPP projects, with the project advisory unit, and Farid Mohammed, chief transaction advisor with the SAPP. Before I hand over the floor to them, I'd like to introduce both of them for this session. Green is a programs manager at SAP's projects advisory unit. She has several years